In this video, we're going to go over some basic math skills that you need to be familiar with for everyday situations. We're going to cover addition, subtraction, multiplication, division, decimals, fractions, and percentages. I may add a few other topics in the course of this video, but let's go ahead and begin. So let's start with addition. What is 3 plus 4? Now, when adding small numbers, a quick and simple way to find the answer is to use a number line. So here's 0. Positive numbers are on the right side, negative numbers are on the left side. So first, let's find the first number, which is 3. Now, what you need to know is that when you're adding, move to the right of the number line. When you're subtracting, move to the left. So we're adding 4 to 3. Thus, we need to move 4 units to the right. So this is 4, 5, 6, 7. Thus, 3 plus 4 is 7. So let's try some more examples. Let's say we wish to add 5 and 4. So let's start with the first number, 5. 5 is somewhere to the right of 0. And then add 4 to 5. 1, 2, 3, 4. So this is 6, 7, 8, 9. 5 plus 4 is 9. Now let's try some different examples. Let's say if we wish to add a negative number to a positive number. Negative 3 plus 5. What's the answer for that? So negative 3 is somewhere to the left of 0. So we're going to add 5 to it. 1, 2, this would be 3, and then 4, 5. So this ends at 2. Negative 3 plus 5 is 2. You can also reverse the numbers. Negative 3 plus 5 is the same as 5 minus 3, which is also 2. If you were to start at 5 and subtract it by 3, that is, go 3 units to the left, this would be 1, 2, and then 3, which will take you to 2 as well. Now, what about this example? What is negative 9 plus 4? Go ahead and try that. So negative 9 is somewhere to the left of 0, and we're adding 4 to negative 9. So we're going to travel 4 units to the right. 1, 2, 3, 4. So this is negative 8, negative 7, negative 6, negative 5. So negative 9 plus 4 is equal to negative 5. Now what about 4 minus 7 and also 5 minus 3? So keep in mind, when you're subtracting, move to the left. So let's start with 5. Let's say this is 0 and 5 is over here. We need to move 3 units to the left. 1, 2, 3. So 5 minus 3 is 2. And then for 4 minus 7, 4 is to the right of 0. So we're going to go 7 units to the left. 1, 2, 3. This is 4. And then 5, 6, 7. This is negative 1, negative 2, negative 3. So 4 minus 7 is negative 3. Thus, drawing a number line really helps you in terms of when you need to add or subtract small numbers. Try this one, negative 3 minus 5. So I'm going to put the 0 here. Negative 3 is to the left of 0, and we're subtracting it by 5, so we have to go 5 units to the left. 1, 2, 3, 4, 5. So that's negative 4, negative 5, negative 6, negative 7, negative 8. Thus, negative 3 minus 5 is equal to negative 8. Now let's try some harder examples. What is 6 minus negative 3? If you were to see that on the math test, what would you do? Whenever you have two negative signs next to each other, it's equal to a positive sign. A negative times a negative is equal to a positive number. So 6 minus negative 3 can be converted into 6 plus 3. You could change these two negative signs into a positive sign. And 6 plus 3, if you start with 6 and then move 3 units to the right, this will equal 9. Now what about an example that looks like this? Negative 7 minus negative 3. If you see that, we could do the same thing. we could change the two negative signs that are next to each other with a positive sign. So this is -7 plus 3. And then at that point, we could use the number line to get the answer. So starting from -7, we're going to travel 3 units to the right. 1, 2, 3. -6, -5, -4. So -7 plus 3, which is the same as -7 minus -3, that is equal to -4. So that's how you can perform addition and subtraction with simple integers. Now, what about adding larger numbers? Let's say 23 plus 45. How can we do this? Well, in school, you've seen problems like this where you can just align them up together and then add. So first you would add 5 and 3, which is 8, and then 4 and 2, which is 6. And that's it for that one. Now what about this one? 35 plus 49. Well, we could follow the same process, but this one's going to be a little different. So first we would add 9 and 5. 9 plus 5 is 14. Now, we won't write 14 on the bottom. We'll write 4 and then carry over the 1. Next, we'll move to the next column and then add 1 plus 4 plus 3, which is 8. So 49 plus 35 is 84. Try this. Add 236 plus 185. Feel free to pause the video and work on that example. So we could use the same process here. 6 plus 5 is 11. Write the 1, carry over the other one. And then we're going to add this column of numbers. 1 plus 3 is 4. 4 plus 8 is 12. Write the 2, carry over the 1. And then 1 plus 2 plus 1 is 4. So 236 plus 185 is 421. And when working out these problems, it's good to check your work to make sure you have it right. So you can take a calculator and just type in 236 plus 185 and just make sure that you have the right answer. So that's how you could do addition with larger numbers. Now let's consider subtracting large numbers. Try these 3 examples. 96 minus 63, 73 minus 45, and also 136 minus 58. So let's start with the first one. 96 minus 63. So what you're going to do is you're going to focus on each column and subtract the large number by the small number. 6 minus 3 is 3. Subtract the top number by the number on the bottom, because sometimes the top number is not always the large number. 9 minus 6 is 3. So the answer is 33 for the first example. Now for the second example, this one is different. So we're going to take the top number subtracted by the bottom number. 3 minus 5 is a negative number, so we need to do something different here. What we're going to do is borrow a 1 from the 7. So the 7 becomes a 6, the 3 becomes 13. Now we can subtract 13 by 5, which is 8. And then we can subtract 6 by 4, which is 2. So we have the answer. 73 minus 45 is 28, and you can confirm that with the calculator. Now let's move on to the next one. 136 minus 58. So once again, we need to borrow a 1 from the 3. This becomes a 2. The reason for that is 6 minus 8 is negative, so we need to borrow a 1. Thus the 6 becomes a 16. Now we can subtract 16 by 8, which will give us 8. And we can't subtract 2 by 5 because that's going to give us a negative number. So we need to borrow a 1. That becomes 0. This becomes 12. 12 minus 5 is 7. So 136 minus 58 is 78. Thus, that's how you can subtract large numbers. And now you know how to borrow a 1 when needed. Now let's move on to the next topic of discussion, and that is multiplication. So let's say if we want to multiply 4 by 3. You could write it that way. This also means multiplication. That's 4 times 3. Or you could put an X in the middle. All of these are different ways to represent multiplication. But what is 4 times 3? Multiplication is repeat addition. So 4 times 3 means that you're adding 4 3 times. It also means that you're adding 3 4 times. You could view it both ways. 4 plus 4 is 8, and then 8 plus 4 is 12. 3 plus 3, that's 6, and adding the other two threes on the right, that's 6. 6 plus 6 is 12. In both cases, you get the same answer. So that's multiplication, repeat addition. Now let's say if we want to multiply 7 by 3. Now you can add 7 3 times, or you can add 3 7 times. It's easier adding 7 3 times, so I'm going to go with that route. 7 plus 7 is 14, and 14 plus 7 is 21. And so that's 7 times 3. So this method helps you to understand how multiplication works. It's simply repeat addition. But nevertheless, I recommend that you memorize the multiplication table up to 12. So it might be wise for you to go to Google Images, look up the multiplication table up to 12 times 12, and just memorize those values, because that's going to help you when multiplying other numbers such as 8 times 6 or 9 times 5 or 7 times 4. It's good to memorize the answers for these. It'll make math a lot easier. But if you don't want to memorize it, you could do it the hard way, which is writing it out. For instance, let's say if you want to multiply 8 by 6. So the best thing to do is add 8 6 times instead of adding 6 8 times. So 8 plus 8 is 16. So this is 16 here, that's 16, and that's 16. Now 16 plus 16 is 32, and 32 plus 16 is 48. So 8 times 6, which is the same as 6 times 8, that's 48. I definitely think it's wise that you commit the multiplication table to memory, for those of you who really want to learn this. Now let's talk about multiplying large numbers. What is 16 times 7? Well, one technique you could use is long multiplication. First, you can multiply 6 times 7, which is 42. What you need to do is write the 2, carry over the 4, and then multiply 7 times 1, which is 7, and then add the 4. 7 plus 4 is 11. Thus, 16 times 4 is 112. Another way in which you could do this is you could break up 16 into two numbers. 10 plus 6 is 16. And then you could use the distributive property. 10 times 7 is 70, and 7 times 6 is 42. And so you're adding 70 and 42 together, which is 112. So that's another way in which you can get the same answer. Now what about 20 times 17? What's the answer for that? Now sometimes you could use money to represent math. If you had 17 $20 bills, how much money do you have? So imagine 5 $20 bills. 5 $20 bills corresponds to $100. Now picture another 5 $20 bills. That's another $100. And then picture another 5 $20 bills. That's 100 as well. So right now we have 15 $20 bills. We need 17. 2 $20 bills is 40. So the total money you would have if you had 17 $20 bills is $340. So 20 times 17 is 340. So you could use money to help you multiply two numbers. Now let's confirm our answer. Seven times 0 is 0. And then 7 times 2 is 14. Now, before moving to the 1, we need to add another 0. 1 times 0 is 0, and then 1 times 2, that's 2. And then we add 0 and 0 is 0, 4 plus 0 is 4, 2 plus 1 is 3. And so we get 340. Now let's work on multiplying large numbers. What's 136 times 54? Feel free to pause the video if you want to work on this example. So first we're going to multiply 6 by 4. 6 times 4 is 24. We're going to write the 4, carry over the 2. And then 4 times 3 is 12. Plus 2, that's 14. So we'll write the 4, carry over the 1. And then 4 times 1 is 4 plus 1, that's 5. Next we're going to add a 0. And then we're going to multiply 5 and 6. 5 times 6 is 30. Carry over the 3. And then 5 times 3 is 15 plus 3, that's 18. So we'll write the 8, carry over the 1. And then 5 times 1 is 5 plus 1, that's 6. So this is what we get. Now we need to add. 4 and 0 is 4. 5 plus 8 is 13. Carry over the 1. 6 plus 1 is 7. So the answer is 7,344. And of course, it's wise to confirm that with the calculator. So that answer is indeed correct. Now what about multiplying decimal numbers? What is 0.25 times 13? Feel free to pause the video to work on that example. Now for this one, we could use money to get the answer. Imagine having 13 quarters. What is the value of money that you have? Now, 4 quarters corresponds to $1. And right now, we have a total of 12 quarters. So we need one more. The last one is just worth 25 cents. So the total amount of money that we have is $3.25. So we could say that 0.25 multiplied by 13 is 3.25. Now let's confirm it. So we have 5 times 3, which is 15. Carry over the 1. 2 times 3, which is 6, plus 1, that's 7. And 3 times 0 is 0, but you don't need to write that. You could if you want to. Now move it to the next row, add a 0. Don't forget to do that. 1 times 5 is 5. 1 times 2 is 2. Don't worry about this one because we used that already. And that's about it. So now we're going to add. 5 plus 0 is 5. 5 plus 7 is 12. Carry over the 1. 1 plus 2 is 3. Now notice that we have two numbers to the right of this decimal. So in our answer, we're going to have two numbers to the right of the decimal. Therefore, the answer is 3.25. So that's how you can multiply decimal numbers. And that's how you can use money to illustrate the math problem and even get the answer. Now let's move on to multiplying certain types of large numbers. 10 times 10 is 100. 10 times 100 is 1,000. And here's a simple way to get the answer. If you multiply 1 by 1, you get 1. And then you need to add the zeros. Here we have 2 zeros on the left. The final answer will contain 2 zeros. For 10 times 100, we have a total of 3 zeros. So the final answer has 3 zeros as well. So let's say if we want to multiply 100 by 100. What I would do is multiply 1 by 1, which is 1, and then add the number of zeros that we have. We have a total of 4 zeros. So then I would just write the 4 zeros. So the answer is 10,000. Based on that, what is 50 times 100? Well, 5 times 1 is 5, and then we have a total of 3 zeros. So the answer is 5,000. If we want to multiply 30 by 200, I would multiply 3 by 2, that's 6, and then write the 3 zeros. So the answer is 6,000. Now if I want to multiply 40 by 600, this will be 4 times 6, which is 24, and then add the 3 zeros. So the answer is 24,000. What about these two? 700 times 800 and also 3,000 times 5,000. 7 times 8 is 56, and we have a total of 4 zeros. So this is going to be 560,000. 3,000 times 5,000, we can multiply 3 and 5 to get 15, and then we have a total of 6 zeros. So the answer is going to be 15 million. So that's how you can multiply large numbers. Now, let's say, for instance, you want to multiply 598 by, let's say, 802. So for something like this, if you want to get a quick estimate of what the answer is, you can round 598 to 600, and you can round 802 to 800. And so 6 times 8 is 48, and then you can carry the 4 zeros. So the answer is going to be close to 480,000. Now let's get the exact answer. 598 times 802. The exact answer is 479,596. So when dealing with large numbers, if you need to estimate the answer, this technique is very useful. Now let's talk about division. Let's say if we want to divide 63 by 9. How can we find the answer? Now what you need to know is that division is the opposite of multiplication. By the way, you can also rewrite this problem like this, as a fraction. So 63 over 9 is the same as 63 divided by 9. Now to find the answer, ask yourself, 9 times what number is equal to 63? And this is one of those situations where it would help you if you know the multiplication table. So 9 times what number is 63? So using the multiplication table, 9 times 7 is 63. Therefore, 63 divided by 9 is 7. And so that's how you could divide numbers. If you know your multiplication table, you can use that to find the answer to division problems like these. So here's another example. Let's say we want to find 36 divided by 4, which is the same as 36 over 4. What is the answer? So 4 times what number is 36? That's the question. Well, we know that 4 times 9 is 36. So 36 divided by 4 is 9. Now what about 28 divided by 4? What's the answer? 4 times what number is 28? The answer is 7. 4 times 7 is 28, so 28 divided by 4 is 7. And that's how you can perform basic division. Now let's work on some examples where we're using larger numbers. Let's say if we wanted to divide 200 by 5. What is the answer? Well, it helps to think of 200 as 20 times 10. 10 divided by 5 is 2. So what we have left over is 20 times 2. And then 20 times 2 is 40. So 200 divided by 5 is 40. That's one way you could do it. Let's work on another example. 4,200 divided by 7. What's the answer? Well, 4,200, you could write that as 42 times 100. And then 42 divided by 7 is 6. So you have 6 times 100, which is 600. So that's the answer for that one. Now what about 24,000 divided by 40? If you see this, the first thing I would recommend doing is canceling a 0. So this becomes 2,400 divided by 4. 2,400 is 24 times 100. And 24 divided by 4 is 6. So you have 6 times 100, giving us the final answer of 600. Let's work on one more example. Let's divide 3,500 by 500. So like before, we could cancel zeros. So we can cancel 2 zeros on the top and on the bottom. So this is 35 divided by 5, which is simply 7. Actually, let's work on one more example, but this time with a much larger number. Let's divide 480,000 by 8,000. In this example, we can cancel 3 zeros. So this becomes 480 divided by 8. 480, we can break that down into 48 times 10. And 48 divided by 8 is 6. And 6 times 10 is 60. So that's how you could divide large numbers. Now what about this example? Let's say if we want to divide 38 by 5. 5 doesn't go evenly into 38. In this case, we're going to get a decimal. This is also known as an improper fraction. To convert the improper fraction into a decimal, you could use long division. So 5 go into 38 7 times. 5 times 7 is 35. 38 minus 35 is 3. Now let's get it add a 0. 5, since we added a decimal point, we need to add it here as well. 5 goes into 30 6 times. 5 times 6 is 30, so 5 times 0.6 is 3.0. And so the remainder is 0. Thus 38 divided by 5 is 7.6. Let's consider some more examples. Let's say if we want to divide 43 by 8. Go ahead and work on that example. So first, we need to determine how many times does 8 go into 43. It helps to write down the multiples of 8, which I'll do over here. So we have 8, 16, 24, 32, 40, 48, 56, 64, and I'll stop it there. 8 times 2 is 16, 8 times 3 is 24, and so forth. So what you want to do is choose the highest multiple of 8 just under 43, and that is going to be 40. So 8 goes into 43 5 times. 8 times 5 is 40. Subtract the two numbers, you get 3. Now 8 doesn't go into 3, so we need to add a decimal point and add a 0. So how many times does 8 go into 30? 8 goes into 30 3 times. If 8 times 3 is 24, 8 times 0.3 is 2.4. Subtracting these two numbers, we get 0.6. Next, we need to add another 0. 8 goes into 60 7 times. 8 times 7 is 56. So the difference between 60 and 56 is 4. Add another 0. 8 goes into 40 5 times. And this gives us a remainder of 0. So 43 divided by 8 is 5.375. So that's how you could divide fractions if the denominator doesn't go evenly into the numerator. And that's also how you can convert a fraction into a decimal. Now let's talk about add-in fractions with different denominators. I won't spend too much time talking about this topic, but for those of you who want more information on add-in and subtracting fractions, multiplying and dividing fractions, or even converting a decimal back into a fraction, check out the links in the description section below. I'll be posting more video content there. You could also visit my website, www.video-tutor.net. On that website, you'll find the playlist that I have on math, algebra, trig, pre-calc, calc, chemistry, physics, and other topics that you might be taking like statistics and trigonometry. So feel free to take a look at that website and the links in the description section below. Now let's talk about adding fractions with unlike denominators. How can we add these two fractions? Well, we need to get a common denominator. To do that, multiply the second fraction by the other denominator, 3. And if you multiply the denominator by 3, you need to multiply the numerator by 3 as well. Now for 2 over 3, we're going to multiply that fraction by the other denominator, that is by 4 over 4. So this will help us to get the same denominator. At the same time, the value of the fraction doesn't change. 4 over 4 is 1. If you multiply 2/3 by 1, it remains 2/3. 3/3 is 1. Multiplying 3/4 by 1, the value of the fraction stays 3/4. 4 times 2 is 8. And then 4 times 3 is 12. 3 times 3 is 9. And 4 times 3 is 12. So notice that 8/12 and 2/3, they have the same value. 8/12 reduces to 2/3. But now, these two fractions have the same denominator. As a result, we can add the numerators of the two fractions. 8 plus 9 is 17, so the answer is 17/12. That's the answer as an improper fraction. To convert this into a mixed number, you could break down 17 into 12 and 5. 12 plus 5 is 17. 12 divided by 12 is 1. So you get 1 plus 5/12, and you could write that as 1 and 5/12. So that's a simple way of how you can convert an improper fraction into a mixed number. An improper fraction is a fraction where the numerator exceeds the value of the denominator. Now let's talk about subtracting fractions. So let's say we have 4/5 and we wish to subtract it by 1/7. What do we need to do here? Just like before, when we were adding fractions, we need to get common denominators. So we're going to multiply the first fraction by the other denominator, that is by 7/7, and we're going to multiply the second fraction by the first denominator, that is by 5/5. 7 times 4 is 28, and then 7 times 5 is 35. 1 times 5 is 5, and the bottom is going to be 35 as well. So now that we have the same denominator, we can now subtract the numerators of the two fractions. So 28 minus 5 is 23. So the final answer is 23/35. Now the numerator is less than the denominator, so this is not an improper fraction. So thus this is our final answer. Now the last concept that we're going to cover in this video is percentages. Let's look at this problem. John's restaurant bill is $80. How much money should he leave on the table if he wishes to tip 20%? Now sometimes if you're at a restaurant and you want to decide how much you want to tip, it's good to do some mental math. You don't always have a calculator with you. Now granted, you could use your cell phone, but this is a good instance where it's good to know mental math in order to get like a ballpark figure if you want to tip 15% or 20%, which is what is customarily given for tips. Now, in this problem, we're not looking for the total price, that is the $80 bill plus a tip. We just want to know the value of the tip that he should leave on the table. So in part A, we want to find out what is 20% of 80. So let's talk about how to do this mentally. First, what is 10% of 80? To calculate 10% of anything, move the decimal point 1 unit to the left. So 10% of 80 is simply 8. Now, if 10% is $8, how much is 20%? 20% is twice the value of 10%. So it's going to be twice the value of $8 or $16. So that's how much money he should leave on a table. The other way to calculate the value of 20%, take $80 and multiply it by 20% as a decimal. To convert a percentage into a decimal, divide it by 100, or you could move the decimal point 2 units to the left. So 20% as a decimal is 0.20. So if you were to type in 80 times 0.20, you would also get 16. Now let's move on to part B. What is 15% of $80? So if he wants to give a 15% tip, how much money should he leave on the table? Well, we know that 10% is $8. What is 5%? 5% is half of 10%. So half of 8 is 4. Thus 5% of 80 is $4. Now to get 15%, we simply need to add 10% and 5%. So 8 plus 4 is $12. So if he wishes to give a 15% tip, he needs to leave $12 on a table. Now, what about 18%? Let's see how we can calculate that. If 10% is $8, what is 1% of 80? To calculate 1%, move the decimal 2 units to the left. 1% is going to be 80 cents. Now, if 1% is 80 cents, what's 3%? Well, 3% is 3 times the value of 1%, so it's 3 times 80 cents. We know that 3 times 8 is 24, so 3 times 80 cents will be $2.40. So to get 18%, we simply need to add 15% and 3%. So we need to add 12 and $2.40, which will give us $14.40. So that will be an 18% tip. That's 18% of $80. To confirm it, multiply 80 by 0.18. 80 times 0.18 is $14.40. Now let's work on another percentage-based word problem. By the way, for those of you who want more word problems on percentages, check out the links in the description section below. Number 2, Karen buys a laptop for $299. The sales tax is 7%. How much money should Karen give the store clerk? So in this case, it's best to use a calculator for this problem. The first thing we need to do is determine what 7% of 299 is. So let's convert 7% into a decimal. We need to divide that by 100. Thus 7% is 0.07. Multiplying 299 by 0.07 gives us $20.93. So that's the 7% tax that she's going to pay for the laptop. Now we're going to take that value and add $299 to it. So the total amount of money that she is going to give the store clerk is $319.93. So percentages is a part of math that is very important to know. When you're dealing with taxes, you need to know how much you're going to pay in taxes. And so having an understanding of percentages will help you to do that. Thus, that's basically it for this video. For those of you who like it, don't forget to hit that like button, comment, or even subscribe to this channel. Thanks again for watching.